Hello everyone. So here we shall solve some more KCET previous year questions on the chapter electric charges and fields. So in the previous part of this chapter we had solved till the question number 8. Now here we shall start from question number 9 onwards. If you have any questions regarding any steps of the question or any other doubts if you have, then please write us in the comment section. Uh, or if you feel you have difficulty in any of the chapters of physics, then also please mention the name of that chapter in our comments section. And also the homeworks will be uploaded. Homework questions on every chapter will be the Sapience education application. Please install our Sapience education application whose link has been provided in the description. Here, question number 9, it is told the electric field at a point due to an electric dipole, an axis inclined at an angle theta less than 90 degree, the dipole axis. So the dipole axis, suppose like this is having minus q charge, this is q charge. So this is the p vector, and then you have to find the electric field at a point, an axis which is inclined at an angle of theta with the dipole axis. Dipole axis perpendicular to the dipole axis. Okay. Here it is told that the electric field is perpendicular to the dipole axis. The net electric field should be perpendicular. Here we can take the components p. This will be p cos theta, and this will be sin theta. So at this point, say A, the electric field due to p cos theta will be 2k p cos theta by r kp cos theta by r cube. If where r is the distance of the point A from the dipole, r is the distance of the point A from the center of the dipole. P sin theta. So due to p sin theta also the electric field will come like this, which is kp sin theta by r. So the resultant electric field should come like this, which is perpendicular to the dipole axis. I tell that this is angle alpha, then this is angle theta, and this will be angle theta also. And if this is at right angle, this is 90 minus theta, should be theta again. So alpha should be equal to theta. That say that tan alpha, tan theta. Tan alpha will be sine, so E sin alpha cos alpha, kp theta, kp sin theta. Is that kp and kp will cancel. So 2 by sin theta because tan theta, that tan theta, tan square theta, tan theta should be Theta should be equal to tan inverse root. Option C is the correct answer. Then in question number 10, it is told in the uniform electric field E, that is equal to 1 into 10 power Newton per coulomb, an electron is accelerated from rest. Electric field of E, an electron is accelerated. Electron is there, accelerated. So initially, the initial velocity of the electron is the velocity of the electron when it has traveled a distance of 10 power minus 2 meter is the velocity we have to find, final velocity that we have to find when it has traveled a distance x, which is 2 into 10 power minus 2 meter. E by m of the electron is given charge to mass ratio, that 10 power 11 kg. So everything is given in SI units. So the force is a constant force, that is Q into E, that is E, and so the acceleration will be E by m into, so that will be constant, that is constant. So acceleration is constant means we can apply the equations of motion under uniform. E square will be equal to U square plus 2ax. Here the displacement is x. E square will be equal to 0 square plus 2 a. A is E by m x. Therefore, square will be 2 into E by m, that is 1.8 into 10 power 2 E, that is 10 power x, that is 2 into, this will be square will be 0.8 10 power 11 plus 11 plus 2, that is 13. You can say 4 square is 4 into 18 10 power. E will be equal to 2 into 3 3 3 9 10 power 6. So this is V is equal to 6 root 2 into 10 power 6 meter per second. Root 2 10 power 6 into root 2, so 0.416, that is 8.4 10 power 6 meter per second. So approximately that is option D. Option D is the correct answer. Then it is told that two fixed charges A and B, 5 microcoulomb each, are separated. Fixed charges 5 microcoulomb is equal to 5 microcoulomb are separated by a distance of 6 meter. C is the midpoint of the line joining charge Q of minus 5 microcoulomb short perpendicular to the line joining A and B. Perpendicular to the line joining A and through C. The kinetic energy this. At point C, one charge Q short with a kinetic energy. Kinetic energy, that is 0. The charge Q comes to rest at a point D. then the distance CD is how much? Say that the loss in kinetic energy that is equal to gain in electrostatic potential energy to the gain in electrostatic potential energy. Gain in electrostatic potential energy. Loss in kinetic energy will be half E initial square minus half m into, but since finally at the point when this charge will reach the point D, it will come to rest. So the gain in electrostatic potential energy will be K Q1 Q2 by R. KQQ by this length is L, then point this is 6 meter, length will be 3 meter. L square root of L square plus 3 KQQ by R. KQ R. KQQ by R plus KQQ. So its length L we have to find. Since the distance CD has been asked, half into M half mv square, which is the actual kinetic energy, joule, that is equal to 2 into K is 9 into 10 power 9, Q into Q, both are 5 into 10 power minus 6 whole square, 5 micro, divided by L square plus 9. Say this is 18 into 5 5 25 into 10 power 9 minus 12 divided by square root of L square plus 9, 0.6. 5 into 3 square plus 9 square plus 10 power square root square plus 9, 2. 5 is of cancel, root of L square plus 9 square plus 9, that 5 by 4 square will be 5 by 4 9. 6 or 2 L square will be 9, 8, Here we have to subtract the initial potential energy. Since loss in kinetic energy means initial kinetic energy minus final kinetic energy. Gain electrostatic potential energy means final potential energy minus initial potential. This will be this minus KQ R. R is equal to, so we have to, so this is wrong. Say that half VI square, that is initially kinetic energy is joule, 2 KQQ, 9 into 10 power 9, 5 into 10 power 6 square, to 1 by square root of square plus 9 by 3. Okay. By square plus 9, 3, that is, so 6 into 10 power 2 divided by 10 power 9, 10 power 12. 3 this is 60 by 10 into 3 is 18, 6 is a 10, 2 by 50, by square root of x square plus 9, it's 1 by square root of 9, same is 50, 7 square plus 9, 15 by 7, that L square plus 9 square, that L square will 15 square is 229, so this will be 15 plus this plus by square root of L square plus 9 will be 3 minus square, 15 is the same, 15 square plus 9, that square, that is equal to 4 meters. 4 meters is the answer. Option D is the correct. Then it's told that the charge on a body is 1 nano, then how many electrons in the charge of one E, that is 10 power minus 9. So therefore, if if on some Q is the net charge on a body, then suppose n number of electrons, then so Q will n number of electrons, Q will be equal to n times the charge of E, Q equal to n. N will be equal to, where Q is the charge on that E divided by the charge of every electron. Nanocoulomb. Nanocoulomb is 10 power minus 9. 10 power 10 divided 10 by 1.6 is 6.5 into 10 power. These many electrons are. D is the correct. Then it's told that two equal and opposite charges of masses m1 and m2 are accelerated equal and opposite charges, equal and opposite charges. That suppose its charge is plus q and its charge is, and their masses are m1 and m. They are accelerated in a electric field. There is a the same distance, the same, that this charge will accelerate towards the direction of the electric field. The negative charge will accelerate the direction opposite that of the, is the ratio of their accelerations. If the ratio of their masses is the acceleration of the first, that will be q by accelerated to the distance. Let the electric field be E, so A1 will be q by m and A2 will be equal to by m2. Therefore, ratio of their accelerations A1 by A2 by m1 by 1 by m2. A1 by A2, that is equal to, option A is the correct answer. Then what is the nature of Gaussian surface involved in the Gauss law? The Gaussian surface, so the Gaussian surface is a vector. Since why? Here we are doing, so according to the Gauss law of electrostatic, we have closed integral E dot ds, that is charge enclosed by epsilon. So here ds means we are using as the, ds is the area vector. This is the area vector at any point on the, so it means that the surface, the Gaussian surface, the area vector has been used. Gaussian surface is vector. Option C is the correct answer. Question number 15. Spherical conductor of radius 2 centimeter is in charge with nano. Spherical conductor is there, is having radius centimeter. Is uniformly charged with charge 3 nano. What is the electric field at a distance of 3 centimeter? The center, spherical 3 centimeter center of the sphere. 3 centimeter means outside the electric. The electric field will be kq by square, kr square. R is the distance from the center, and inside the conductor there will be 9 into 10 power 9 charge is divided by r square, which is 2 centimeter 10 power square. This much Newton per coulomb, volt per meter. The 27 divided by 4 10 power is the distance 3 centimeter 3 centimeter 10 power 10 9 is the 20 meter. And A is the then it is told the angle in the dipole and the electric field at any point, the angle between the dipole, the equatorial plane of an electric dipole, excuse me, q, angle between the dipole and the dipole is p, like this. Electric field at any point, the electric field will be directed opposite to the dipole vector. Electric field at any point minus kp by r cube. So it means therefore the angle in between them is 180 degrees. D is the question 16 is option D. Then question number 17 is pick out the statement which is incorrect. The electric field lines from fields lines never intersect. The tangent, the line of represent direction of the electric. If test charge experiences of opposite, so option A is wrong. Why electric fields never form closed loops? Since why electric field is a conservative field. Electric is a conservative. Is a electric force is a conservative force. So work done in a closed loop is zero. Work done by an electric field, so they don't form the electric field. So option A is the correct answer since the statement is two spheres carrying charges plus 6 microcoulomb and plus 9 microcoulomb separated by a distance d. Spheres here it is having plus 6 charge, here plus 9 charge. They are separated by a distance d. Experiences a force of repulsion F when a charge of minus 3 microcoulomb given to both the spheres and kept the same distance as before, the new force of repulsion is when a charge minus 3 microcoulomb given to both the sphere. So their force will be F equal to K into Q1 into Q2 10 power minus 6, so minus 12 divided by square. When a charge of minus 3 microcoulomb is given to both the spheres and kept at the same distance as, then the new force of repulsion, so now their charges are changed. One is 3 microcoulomb and one is 6 microcoulomb, and their distance of separation is d only. Then the new force of repulsion is F dash. So that will be F dash will be equal to K into Q1, Q2, 10 power divided by, this is equal to, therefore we can see that F dash by 3 6 is 18, that is coming equal to F by, since why they both are equal to K into 10 power by d. So therefore we can say that 54F dash, that is 18F. 3 is 18, 6, 9 is a 50. F dash, that is equal to F by 3. So option D is the correct answer. Then question number 19, it is, if there is only one type of charge in the universe, if there is only one type of charge in the universe, then E is the electric field, ds is the area vector. Type of charge is there, so then option D is the correct answer. Since according to the Gauss law, the rule is that closed integral E dot ds to net charge enclosed by epsilon. If there is only one type of charge in the universe, then Q enclosed will be equal to if all the charges are outside. If charge is outside and charge is inside, then it will be by epsilon. So option D is the correct. An electron of mass m, charge E, distance h meter in an, there is an uniform electric field which is acting vertically upwards, and one electron fall downwards through a distance h, downwards h, its mass is m, then the time of fall is how much? Time of fall, first we have to find the acceleration. Acceleration will be by the electric force by, now since acceleration is constant, there that the displacement is equal to t plus half. Since it falls down, there initially it was at rest. S is h is equal to half into by m, time of fall over 2 hm by e. Actually, the option A is the, then number 21, it is told that EAX and EQ represent electric field at point on the axial and equatorial line of a dipole. If points are at a distance r from the center of the dipole are much greater than A have. So here that the electric field on the equatorial plane at any point K minus Kp by r cube, and electric field on the axial, that is, or we can say that the electric field on the axial minus 2 times, so option C is the correct answer. Then it is told two spheres of electric charges plus 2 nanocoulomb and minus 8 nano placed at distance d apart. If they are allowed to touch each other, what is the new distance between them? Get a repulsive force same magnitude. If they are touched, then the charges will get redistributed. So they are touched, then the final charges will be the new charge q, that is equal to q1 plus q2 by 2 minus 2 minus 8 by 2 minus 6 by 2 minus 3 nanocoulomb. Since why the net charge of the system should remain conserved, is according to charge. This point is q, it is also q, which is 3, is also the new distance has been, let it be d1. This d1 should, such that the force should be same, should be of magnitude. Initially the force was k into 10 power minus 9 18 q2 by d square. Here force should be the same, k into 3 10 power divided by d1 square. Therefore we can see the force is same. It will be like 9 by d1 square, that is equal to the 16 by d square. By both are equal to fd square by k 10 power 15. Since why, sorry, both are f by k into 10, say that 3 by d1 d, that d1 3d. Option C is the correct answer. It is told that 4 into 10 power 10 electron metal sphere diameter the d is 2 centimeter is placed in the magnitude of the electric field at a distance of 3 centimeter. The radius is 10 centimeter. At a distance of 20 centimeter outside the sphere. Now it is a metallic sphere, so it's a spherical conductor. Spherical conductor. Since it is a metallic sphere, it is a spherical conductor. Therefore, you have to find how much is the charge. 10 power 10 electrons. Here, positive charge only electron. Q will be 10 power 10 n into 6 into 15. This will be 1664 10 power 6 for coulomb. The electric field at a distance of 20 centimeter from the center, this will be kq by r square. K is 9 into 10 power 64 r, which is 20 centimeter 10 power square. It's 1. 9 into 10 power 9 into divided by 10 power 16 64 cancel out, then this will magnitude of the electric field into 10 power 10. This will 10 power minus 9 is wrong. This will be 64 10 10 be 9 into 10 power 9 and 10 by this is here, so this will be 9 into 60 10 power minus 1 4 64 9 into 60 10 16 nines are 10, that is 1440 Newton per. This is the electric field. Three point charges of Q, 2Q and minus 4Q placed at the corners A, B and C of an equilateral triangle. Lateral side X. C, side length is X. The point charges are 2Q, 2Q charge, 4Q charge is placed. The magnitude of the electric dipole of this system is magnitude of the electric dipole of this. Here we can say this is one dipole, this is one. So this minus 4Q, I can say it is minus 2Q and another. This is one dipole is along CA and this is another dipole, and magnitude of the electric dipole of the system. The this is, I can say this dipole is P1 vector. This is equilateral triangle, so angle theta is 60 degrees. So P net P1 plus P2. Now therefore magnitude of the net electric dipole of the system be equal to so their magnitude will be the same. Magnitude of P1 equal to magnitude of P equal to P, suppose that will be equal to Q, that's 2Q into X. This will be square root of P1 square plus P2 square plus 2P1 P2 cos theta. P is same, so this is P square plus P square plus 2 degree. 60 is half over 3P square, 3P. So therefore the magnitude of the net dipole of the system, that is equal to P 2QX, that is 3QX. Then it is told the magnitude of point charge due to which the electric field 30 centimeter away as the magnitude turn per. The magnitude of point charge Q is the electric field at a distance R. R is 30 centimeters, a magnitude of this Q we have to find. Therefore we know that the electric field, the point charge at a distance R from the point, it is given 2kq by R square. Therefore we can say 9 into 10 power 9 cube 30 centimeter 10 power minus square. R is 30 into 10 power minus 2 meter, which is 10 power, that is equal to 2. This is 10 power 9, 9 into cube 10 power equal to 2. 9 and 9 will cancel. Is equal to 10 power divided by 10 power 9. Therefore, the charge q, that is equal to 10 power minus 11. Option A is the correct answer. Then here it is told the force of repulsion in between two identical positive charges. The force of repulsion in between identical charges when kept with a separation r in A. This force is equal to k cube square by r. Half the gap between the two charges is filled by a dielectric slab of dielectric constant in between charges comes. So that half of that is filled by a dielectric slab of thickness r by 2, and the dielectric constant k, that is equal. Dielectric constant, we can say it is epsilon r. So the net force now to k, that if the thickness is t, the dielectric constant is k, then r should be replaced with r minus t, where air is there. Air is there in the region, the length r minus t. Then the thickness we have got, the thickness t, we have got the dielectric slab. So this will be t root k. Place this. That the force F dash, that here the initially the force was, this is 1 by 4 pi epsilon. This will be by 4 pi epsilon q square by r minus t root k square. There should be by 4 pi epsilon r minus t is r by 2, so k root k square by 2 and cancel. So r plus r by 2, 3 r by 2 square, r by 2 square. So this is 4 by 9 to q square by 4 by epsilon. Q square by 4 by epsilon naught, that is a. Option D is the correct answer. Then it is told that certain charge 2q is divided at first parts q1. Certain charge divided into two is q1 and q2. That q1 plus q2, that is equal. Later the charges are placed at a certain distance. Certain distance in between them d. The force of interaction charges is maximum. Interaction between charges maximum. Then q by q1. Now q2 will be equal to 2q minus q1. To find q by q, the ratio. Therefore, the force of interaction will be k into q1 into q by d square. this will be k into q1 2q minus q1. This should be maximized. F is a function of q1. For f is maximum, this is max, then df by dq1 d square f by dq square less than, then q equal to q1 of equal maximum. Here we are using the maxima. Therefore df by dq, this will be df k by d square is constant, come outside. Q minus q1, q1 in this will be 0 1, so that is equal to 0. That plus this is this q1 in p2 minus q1 q1 to that q by q. When q is q, then d square f by dq square f by dq1 square, that will be k by d square 0 2. This will be obviously less than that. Q equal to q1, then only we will have the maximum value of the interaction. Option A is the correct. So then told an electric dipole is kept in electric. An electric dipole is there, charges q, it is kept in an electric field. If the electric field is uniform, then it will experience torque. Torque is given as E cross, where E is the external, and force it will also experience when electric field on E. If the electric field is uniform, it will experience both torque and force. Experience torque also, and if the electric field is uniform, then it will experience torque, but it will not experience. Option B is the. Then told an infinitely long thin straight wire, infinitely long thin straight wire is there, long infinitely long thin straight wire is there, has a charge density lambda, which is q by charge per unit length is L, the charge is q, 10 power meter. What is the magnitude of electric field at a distance 20 centimeter axis of the magnitude at a distance of, so it is infinitely long. What is the electric at a distance of 20 centimeter? So we know that here, if I use the Gauss law, that closed integral E dot ds means that if we assume one cylindrical Gaussian surface, say that electric field in the surface, the curved surface area is 2 pi r equal to charge enclosed at q lambda by epsilon is 2 pi r into L. L will cancel, then we will have electric field will be lambda by 2 pi epsilon. This is actually 2 lambda by r. The electric field is given as 2 lambda by r. Therefore, the electric field at a distance r from the axis of the infinite k lambda by r. K, here r is 20 centimeter, that is meter. K is 9 into 10 power 9. Lambda is 1 10 power minus by r. R is 10 power 9 by 10 9 is 1 9 by 4 10 power 8. So 8 10 power 8 Newton. Option A is the. Then question number 30, it is told point charge Q is placed at the corner of the corner cube side A shown. What is the electric flux through the face ABCD? What is the electric ABCD? Cube spaces there. Point charge Q is placed at the corner of it. In one corner display side A. What is the electric flux through the face ABC? So point charge is placed in the corner. The electric flux, the electric field lines will pass along the surface, the face. That no electric field line will cross this. Line will cross this. Therefore, the net flux 0. Since we know that flux phi E, that is given as dot A is EA cos theta. The electric field lines are going along the surface only. Therefore, cos theta at A vector is the normal vector perpendicular. A vector is perpendicular to E vector here. Theta is 90, so EA cos, that is. When the electric field lines are going along the surface only, then there will be no electric field that surface. The net electric flux through face ABC C answer. Then shall solve the okay, so questions we shall solve chapter KCET. So question number 31 told the electric field lines on the left have twice separation. Electric field lines on the left twice the separation those right. Shown the magnitude of the field at A. So the the magnitude field at A is 40 per meter is the force on a 20 coulomb charge kept at B. So the electric field on the left have twice the separation. So it means that the electric field is higher. The field at A, that is twice the electric field at B. That the electric field at B is the electric field at B is the electric field at A by 20 volt per meter. Is the force on a 20 microcoulomb charge kept at 3 into 10 power Q is given 20 microcoulomb, 10 power minus 6 coulomb. T 4 10 power 10 power minus 6, so 10 power minus 4 meter. So actually it should be done. Can be written as some volt. Actually the units which are given in the those are wrong. The unit should be given as the, the force. Option C is the correct. Then we'll solve the last question. When a soap bubble is charged, the radius remains the same. Radius may or decreases. The rule is that when a soap bubble is charged, then due to repulsion between the nearby charges, there is some repulsion in by charges which results in the expansion of these charged. So the bubble will expand due to the repulsion between the repulsion between the nearby charges, repulsion between the charges, the surface, the charged soap bubble, the charged bubble will expand. So it means the radius in radius of the bubble will. That option C is the. So hope you all have understood the solutions of all these 32 questions on this chapter. Yes, exam. So if you have any questions in any steps of the other kinds of doubts, if you have, then please write us in the section. Also, please install our Sapience education application where we shall upload some very important questions, the chapter which you shall solve your shall be helpful CET exam. Here we shall end our class related to charges and fields. So see you all in the next video, the next chapter. Thank you.